Okay, problem 1 on the study guide. Find a number which decreased by 57 equals twice the opposite of the number. So our directions are to find a number. So let's say x equals the number. Okay, and a number which decreased, so they're saying the number is decreased by 57, so the number decreased by 57 equals is an equal sign, and then twice is 2 times. And then it says the opposite of the number. So if x is the number, then negative x is the opposite of the number. So that's how we create the equation. Once we create the equation correctly, I would probably make it a little prettier. So x minus 57 is equal to negative 2x, would be probably the best way to write it. At this point, this is a 1x on this side, negative 2x on that. So I don't want those x's on the same side, so I move this 1x over. Positive 1x becomes negative 1x. What's left on the left-hand side is negative 57. The minus sign sticks with it as a negative. Negative 2 and negative 1 are the same sign, so we add those together, making the answer negative because 2 is bigger. Then we simply divide both sides by negative 3. 57 divided by 3 equals 19, and 2 negatives when you divide make it positive. So x equals 19 is the correct answer in number 1. Number 2, 8 times number is 30 less than twice the opposite of the number. Find the number. So again, here's our directions. Find the number. So x equals the number. 8 times a number, 8x, is equals. If you have a less than or greater than, we ignore that. So 30 less than, ignore that for right now. And then twice means 2 times. And then it says the opposite of the number, that's negative x again. So that much is everything but the highlighted part, and we get to the period, so the equation's done. Once we're done with the equation, we deal with the less than part. The word is equals, 30 less than is occurring after the word equals. So after the equals, we fix the right-hand side by doing a minus 30. You always fix the side, if it's before is, you fix the right-hand side by putting it right there. If it's after is, it's usually after is, then you fix the right-hand side just by putting a minus or a plus 30. If it says more, plus 30, less, minus 30. And at this point, again, there's the equation. I would probably beautify it a little bit. So 8x is fine. 2 times negative x is negative 2x. And minus 30 is fine. Once again, I've got x's on both sides. I'm going to take this 2x, move it to the left. Negative 2x moves over as a positive 2x. 8 plus 2 is 10x. Negative 30. And we simply divide both sides by 10. That gets me x equals negative 3. 30 divided by 10 being 3. And of course, opposite signs get you negative when you divide. Number 3, right, 225 is a product of prime factors. We are looking for prime factors, so prime numbers 2, 3, 5, 7, 11, 13, and so on. The first thing to do a factor tree is simply find a single number that you know goes into it. 25, since the last 2 digits are 25, 25 goes into it, so 25 times 9. 25 is 5 times 5, and 9 is 3 times 3. So that's the answer. 3 squared times 5 squared. Just so you know, there's more than one way to do this. 225, if you know that 5 goes into it because it ends in a 5. 5 is already prime, 45 is 9 times 5. 5 is already prime, 9 is 3 times 3. And then 5 is already prime. You get the same result regardless. A real simple, quick way to check this is make sure these are all prime numbers and then verify they actually multiply to make 225, which if you did that on a calculator, 3 times 3 times 5 times 5 equals 225. There's your answer. So, product of prime factors, I would accept the power form or even just the written out form like that. Use raised dots, not x's for multiplication, please. Number 4, simplify negative 3 to the negative second power. So what's being raised to the power? Anytime you see a power, you have to ask yourself that question. What's being raised to the power? The only thing being raised to the power is 3. The minus sign is not being raised to the power. And currently it's in a whole number structure. So minus is there. I've got 3 being raised to the negative second power, and officially it's over 1. So first thing we want to do with the negative power is move it where it belongs. So this with the negative power belongs in the denominator. So if I do that movement, 1's on the bottom, minus sign's still on top. The 3 squared's moving to the bottom, it's going to multiply by what's already there. And once I move a negative power where it belongs, the power changes to positive. So negative 2 changes to positive 2. I'm left with a minus sign on top, nothing attached to it. Officially there's a 1 attached to it, so I'm going to put a 1 there just to keep in mind there's a number there. Officially there's a 1 being multiplied by that 3 to the negative second power, so that's where the 1's coming from. All it's have to do is to evaluate this. Negative 1 can't be made any simpler. 3 squared, which is 9, times 1 is equal to 9, so negative 1/9 is the answer. Negative powers do not make negative numbers. The minus sign is making it negative. The 3 to the negative second actually makes the fraction happen, so be careful of that with negative powers. Number 5, same deal. We have a negative power involved in the problem, and again, we have what's being raised to the power. In this case, only the 2 because there's no parentheses involved. So if I rewrite this, 1 is 1 over a minus sign, which is not being raised to the power, and it's being multiplied by 2 to the negative third power. This is all that's being raised to the negative third power. So this belongs in the numerator with the 1. So 1 is still there. We're multiplying it times 2 to the third power. There's still a negative on the bottom. And that negative officially has a 1 attached to it. All right? At this point, 2 to the third power is equal to 8. 8 times 1 is equal to 8. And positive over negative makes a negative. 8 divided by 1 is 8. So negative 8 would be the best answer for that problem. So a negative power can also make a non-fraction. If you start off in fractional form, the negative power can actually move up to the top, creating a positive, just a whole number orients your answer. Number 6, we're solving an equation. Anytime you're solving, you're trying to find the value of the variable x in this case. The only concern I had to begin with in this, as far as simplifying is concerned, is I have a distributive property happening here. Be very cautious. Distributive property has to do with what's being multiplied by the parentheses. 2x is not being multiplied by the parentheses. The minus sign, which is officially minus 1, is being multiplied by the parentheses. So the 2x is going to stay 2x. What I'm going to get out of this highlighted part is going to be negative 1 times 4x, which makes minus 4x, and negative 1 times negative 5, which makes positive 5. So you get these signs, positive or negative, that translates to minus or plus. So negative times positive makes a negative, so minus 4x. Negative times negative makes a positive, so plus 5. Everything else in the equation stays the same also. So plus 2 is still plus 2, equals still equal, minus 3x still minus 3x, plus 6 still plus 6. That's priority 1. Priority 2 is looking at both sides individually. So I have my left-hand side right here, and I got my right-hand side over here. I want both those sides simplified as much as possible. That means like terms combined together. So on the left-hand side, what I'm noticing is 2x and negative 4x are like terms. I'm also noticing that positive 5 and positive 2 are like terms. So 2x minus 4x makes negative 2x. I subtract it because the signs are different, and it's negative because 4 is bigger, so we keep that sign on the answer. 5 and 2 are both the same sign, so I add those together, and they're both positive, so I get a positive. Over on the right-hand side, there's only one x term, only one number, so the right-hand side is perfectly fine the way it is. This is the point I want to get to with every equation. At most, a letter and number on one side, a letter and number on the other side. So at this point, I need to just rearrange the problem. I want x's on one side, numbers on the other. I'm going to take the negative 3x and slide it over here. Negative 3x becomes positive because I moved across the equal sign. I'm going to take the positive 7, move it over there. This positive 7 moves over as a negative 7. The negative 2x and the positive 6 stay right where they were, so they're staying negative and positive as they were. And then here I either add or subtract based on signs. These signs are different, so I subtract, so I get 1x. 3 is bigger, so it's positive. These are also opposite signs, so I subtract. 7 is bigger, so it's negative. If 1x equals negative 1, that just means x equals negative 1. The last step would be to divide by the coefficient. Dividing by 1 doesn't do anything, so there's your answer for that problem. Number 7, same deal. We got an equation we're trying to solve. Again, we have a distributive property situation right here. And again, officially there's a 1 in front of that parenthesis, so minus 1 is being distributed there. And I got a second parenthesis here, and 3 is being multiplied by that, it's positive 3. So anytime you do this distributive property, consider not just the number, but also the sign attached to the number as you multiply through. So if I go ahead and do this, the negative 2p stays negative 2p, the minus 5 stays minus 5. This minus 1 times these things distribute, so minus 1 times 3p makes negative 3p, which is equivalent to minus 3p. And negative 1 times negative 26 is positive 26, equivalent to plus 26. Equals 5 is going to stay equals 5, and then I do a distributive property here. 3 times 2p is going to make positive 6p. 3 times 4 is going to make positive 12. So again, priority 1, get rid of the parentheses by the distributive property. But again, focus on what's being multiplied. Some of you are still trying to deal with this in terms of that, but the plus or minus sign is what matters. And then the number is assumed to be a 1, otherwise, unless it's actually written, in which case it's the number it is. Next thing I do is look for like terms on the left and right hand side individually. So the left hand side is here, the right hand side is here. We're looking for like terms on either side. So in the blue highlights, I can see that negative 2p and negative 3p are like terms. They're both negative, so I add them together. 3 is bigger, so it's negative. I also see that negative 5 and positive 26 are like terms. Those are opposite signs, so I subtract. 26 is bigger, so it's positive. On the right-hand side, 6p is the only p term, so nothing happens to it. It stays positive 6p. And I've got 5 and 12 are both numerical terms, so 5 plus 12 is equal to 17. Addition because the signs are the same, and positive because 12 is bigger. So again, I get myself to this point. Now my last step is to get everything on one side p and everything on the other side not p. So I'm going to move the 5p, negative 5p over here, becomes positive 5p. I'm going to move the positive 17 over here, makes negative 17. These signs are different, so I subtract. 21 is bigger, so it's positive. These signs are the same, so I add. 6 is bigger, so it's positive. And if 11p is equal to 4, we divide both sides by 11. P ends up equaling 4 elevenths. And I would prefer a fraction to a decimal, so make sure you do that properly. Number 8, factor the greatest common factor. So, we look at each term individually. We have 2 x squared y cubed and we have 4 x cubed y squared. Instead of looking at them as 2 and 4, I'm looking at them as 2 and 2 squared. 4 is the same as 2 squared. X and y are already there. So if I'm finding the greatest common factor, the GCF, what I'm concerning myself with is what's the same, what's common. And what I'm noticing is common here is these are common. The 2's are common. The x's are common. And of course the y's are common. So both of these terms contain common pieces. So if I look first of all at what's common, we got 2x and y, so I write 2 times x times y. And then what I'm concerned with is the lowest power of each one. That's what I care about. So for 2, my choices are 1 and 2, I'm going to take the 1. For x's, my choices are 2 and 3, I'm going to take the 2. And for y's, my choices are 2 and 3, I'm going to take the 2. Okay, that's how you determine the greatest common factor. Now the directions here say factor the greatest common factor. So what I need to do now is, there's my common factor. If I make it pretty, it's going to be 2x squared y squared. No multiplication symbols are necessary to show multiplication of a number and a letter, or a letter and a letter, so 2x squared y squared is sufficient for that. And then what I want to put here is what's left over from each of these pieces. So there's a plus sign in the middle, so I put the plus sign because that's what that is. If it said minus, I put minus. What's circled in blue, I'm going to divide by 2x squared y squared. And until I get to the end, I'm not going to write down numbers unless I have to. So 2 divided by 2 is 1. Keep that on the back burner. X squared divided by x squared cancels. Y cubed divided by y squared is y. So it's 1y or just y. If you want to write the 1, it's not wrong to do that, but you only have to write the 1 if everything disappears. All right, so y is what's left over from the blue. For the red, 4 divided by 2 is 2. I'm going to go ahead and write down a number that isn't 1, so 2 is fine. X cubed divided by x squared is x. Then y squared divided by y squared cancels. This is what factor the greatest common factor looks like. You find the common factor, and you write the leftover pieces. If you want to verify the correctness of this product should equal the blue term, 2x squared y cubed. This product should equal the red term, 4x to the third y squared. So if you did a distributive property on your answer, you should end up with the original problem as is. Number 9, same deal, greatest common factor. A quicker way to do greatest common factor that you might prefer. You look at the numbers 12, 18, and 24 and ask yourself, what's the biggest number that divides those evenly? And you come up with 6. And then we have A, 1, 1, 2, we'll take the 1. We have X, 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 we have 2, 1, 1, we'll take the 1. We have Y, 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 we have 1, 1, 2, we'll take the 1. So 6AXY is the greatest common factor of those terms completely. And for the sake of writing an answer, I don't put the first powers on usually, so I'll just keep those off. And then again, it's just a matter of taking each term individually and dividing by this common factor. So 12 divided by 6 is 2, 8 divided by 8 cancels, x squared divided by x is x, y divided by y cancels. Then I had a plus sign. The next term, 18AXY. 18 divided by 6 is 3, a cancels, x cancels, y cancels. Then I got a minus sign. And then my final term, 24a squared xy squared. 24 divided by 6 is 4. A squared divided by a makes a. X divided by x cancels. Y squared divided by y is y. Looking at the parentheses here, nothing divides evenly into 2, 3, and 4. So that verifies we took the biggest number out. This has x, this has nothing, this has a y. There's no other common pieces there. So we did take out the greatest common factor, and we got the best answer possible. And again, verification simple. This times this should make that 12a x squared y. This times this should make the middle 18axy. This times this should make the last negative 24a squared xy squared. So if you get the original problem through the distributive property, that means your correct answer is on your paper. Number 10, simplify 12 minus 6x over 6. Now, if you take a look at the binomial structure at the top and look at a common factor of that, ignore the bottom as we do this. The biggest number that divides 12 and 6 is 6. Nothing divides x and nothing, so x isn't a common factor. If I take 6 out of this the same way we did in the last two problems, 12 divided by 6 is 2. Negative 6x divided by 6 is negative x. And again, if you verify that this is correctly factored, 6 times 2 should make that, which it does. 6 times negative x should make that, which it does. Once you get it factored and you have a product over a number, this factor matches that factor. We cancel those, we get 2 minus x as an answer. So factor the polynomial, and then whatever the common factor is that you can take out, you can reduce with anything individually on the bottom. Number 11 works the same way, looking at the top only. The biggest number that divides 18 and 6 is 6. Both objects contain the letter x, so I'm going to take an x out also. 18 divided by 6 is 3. X squared divided by x is x minus. 6 divided by 6 is 1. X divided by x cancels. So 3x minus 1 is left when I take a 6 out of the top. And again, if I verify that this is correctly factored, 6 times 3 is 18, x times x is x squared. 6 times 1 is 6 times x makes minus 6x. So that's the correct factored form. This matches this, they cancel, so 3x minus 1 is the result. Number 12, expand by using the distributive property. So we're going to take this object and multiply it by that, and we're going to multiply that same object by this. So if I do the green multiplication first, 4 times nothing makes 4. X squared times x to the negative third makes x to the negative first. We add powers when we multiply letters. 2 minus 3 is negative 1. For y, 4 plus 1 makes 5. So that first term becomes 4, x to the negative first, y to the fifth. We'll leave that for now. 4 times negative 2 is negative 8. X squared times x cubed makes x to the fifth. And y to the fourth and y to the negative fourth make y to the 0. So that's priority 1. Do the multiplication, get what you get. With letters of the same type, you add the exponents of the letters that are there. using good addition rules. These are different signs, so I subtracted. 3 is bigger, so it's negative. Same sign added, they're both positive. Same sign add, both positive. Opposite sign subtract, and their 0 has no sign, so it's irrelevant. That gives you half credit for an answer on the test. To get full credit, we have to then fix the negative powers and 0 powers. So this term here and this term here are separate terms. They're dealt with separately. So in the green term, 4y to the 5th are both positive power objects. 4 is to the first, y is to the 5th. X is to the negative first power, so it belongs on the bottom. So you put that on the bottom. And that's the end of that term. The minus sign occurs. And what's wrong with the second term is y to the 0, which equals 1. Times 1 doesn't do anything, so 8x to the 5th. That's how you should write your answer. Notice this fraction bar does not extend beyond the minus sign. So this is the fraction, this is a non-fraction. Treat each term individually with that situation. So if a negative power happens in a term, it creates a fraction only in that term. It doesn't create a fraction for the whole problem. And that's what I'd expect your final answer to look like on that one for full credit. Number 13, same deal. Expand using distributive property. We have an outside object here, d over c, being multiplied by the inside objects. So I'll do a red multiplication and a blue multiplication. When you're dealing with fractions, do fraction multiplication. There's no common denominator necessary to this. It's just a matter of multiplying top and top and bottom and bottom. So when I do the red multiplication, d over c times 12e over d, d times 12e on top makes 12de. C times d on the bottom makes cd. When I do the blue multiplication, d times negative 5d makes negative 5d squared. D times d, you add the powers, so you get d squared. On the bottom, c times e is ce. That answer gets you half credit. Okay, it's right, but it's not fully right. The reason it's not completely simplified is because that this d and this d, one on top, one on bottom, those cancel out. So the final step with this, again, in simplifying it, with the last one had negative to 0 powers to deal with. This time we have multiple letters of the same type within a term to deal with. So what I'm going to do to fix this term, I'm going to strike the d's out. That leaves me with 12e on top over c. And again, that's its own term. That fraction's done. Then the minus sign occurs. There's nothing wrong with this term. 5 is to the first power, it's positive power, d squared positive power, c and e positive powers. All the letters are different. That's what simplified looks like. So that one's perfect the way it is. But since we modified the red, we're just going to bring this down. There's no need to add the fractions. Just leave it in separate fraction form like that, over c over ce. No common denominator, so no addition or subtraction is possible at this point. Number 14, evaluate m times a to the 0 minus ma times negative m plus the absolute value of m squared minus 2. First thing I would do is I'd take this entire expression and beautify it up a little bit. First off, I've got a single object m being multiplied by a single object negative m being multiplied by this binomial. So what I would do is I would put these two m's together. Let me just highlight that. This m and that m are all being multiplied through that parentheses. I'd make it negative m squared instead of m times negative m separately like that. Also, a to the 0 power equals 1, no matter what a equals. So I would probably just call that a 1 minus ma. So that first piece here, which is all this here, is the same as right there. You're going to get the exact same expression on the test, so know that's possible. The second expression I can't make any prettier than it is, plus absolute value of m squared minus 2. So I'm going to leave that as is. Now looking at this object, I've got two specific types of things happening in this object. I've got an m squareds here and here, and I've got am or ma happening there. If I can evaluate those before I start substituting in, it makes my life easier. So if I start off with m equals 3, that means m squared is equal to 9. So that's helpful. And if a equals negative 4, m equals 3, and I'm looking at ma, right? M equals 3, a equals negative 4, so 3 times negative 4 is what ma means, which is negative 12. So now instead of replacing this with a 3 and this with a 3 and a negative 4 and that with a 3 and then squaring and multiplying and all that other stuff, I can just come over here. This says negative, I put negative. Then it says m squared, which is 9, parentheses 1, minus, and it says MA, which equals negative 12, plus the absolute value of m squared, which equals 9 minus 2. Okay, so the green and the red, m squared equals 9, ma equals negative 12, just substitute in there very easily, and I've already taken care of the multiplication and the powers, and I'm left with a simpler problem. Order of operations in this sense, negative 12 makes plus 12, so I get this is a term plus this is a term. So I have to evaluate that, evaluate this, then add or subtract based on signs. So this part here, 1 plus 12 is 13. Negative 9 times 13 is 117, and it'll be negative because of different signs. And 9 minus 2 is 7. The absolute value of 7 is 7. And then at this point, I've got this as pretty as I can get it. I got this as pretty as I can get it. Now I've got to deal with the addition or subtraction. The signs are different. I subtract, and 117 is bigger, so it's negative. So negative 110 is the solution to that one. And finally, negative 3 times negative 4 minus 2 over negative 8 to the 0 times negative 1 minus 2. Once again, we're dealing with a power structure here. What's being raised to the power is 8, not the minus sign. So be careful of that. The top, I've got negative 3 times negative 6. I'm adding those because the signs are the same. It's negative because 4 is bigger. Negative 3 times negative 6 is positive 18. 18 because that's what 3 times 6 is. Positive because they're both the same sign. On the bottom, I'm going to start off. Negative 8 to the 0 is going to be negative 1. Again, this makes 1. The minus sign is not being raised to the power, so leave it negative. Inside the parentheses, negative 1 minus 2 is negative 3. Addition because the signs are the same. Negative because 2 is bigger. 1 times 3 makes 3, and 2 negatives make a positive. Once I get the top result, which is 18, that's being divided by the bottom result, 3. The answer is the quotient of that, which is 6. Same sign gets you a positive answer, so positive 6 is the solution to that one.